All right, so today we are talking about section 8.2. Today is all about measures of angles in polygons. We'll have two big ideas today, and I think for the most part you'll find this lesson to be pretty easy. Anybody need more time with the objective? All right. For our warm-ups, we're doing a throwback to 8.1 that we talked about on Wednesday. Concave versus convex. On number 1, what type of shape do you think that is? Concave, very good. Remember, if any of the sides would turn into lines that go into the figure, like this one over here would go into it, then it is going to be concave. The other way we thought about it is to see if it looks like it's dented. If it's dented inward, it's concave. Number 2 is convex. If we go all the way around and turn all of the sides into lines, none of them cut into the shape. Questions, concerns about our warm-ups? Need more time? On we go. Oh, yep.
Shapes that goes inside?
Yep, if the side of it would go inside the shape when you extend the line, then it's concave. Not all of them have to go inside. Like if I were to look at this top line, that one never goes inside. But some of these other ones do. So if even just one side would go into it, then it's concave. All right. For today, our first big idea is to talk about the interior angles theorem for polygons. So interior, meaning inside. The sum, also a big idea here, the sum of the interior angles of a convex polygon with n sides is n minus 2 in parentheses times 180. So let's talk about this just for a minute, because some of the polygons that we would deal with you're already familiar with. What does it mean to have a sum of the interior angles? We would add up all the angles, right? It's the sum of the interior angles. So this is what the number you would get if you added up all the angles. For example, if we were to talk about a triangle, how many sides does a triangle have? 3. So for n, we would put a 3. We would have to do our order of operations. 3 minus 2 would be 1. 1 times 180 is 180. But you already knew that, right? You should have already known that all the angles in a triangle should add up to 180. We could do the same thing for a quadrilateral. For a quadrilateral, how many sides does it have? 4. What's 4 minus 2? 2 times 180, 360. But you already knew that. If you add up all the angles in a quadrilateral, you should get 360. This is just going to allow us to find angles in other polygons as well, because we could plug in any number of sides here to find out how much all the angles should add up to. Questions, concerns? Need more time on this slide? Okay. We'll keep it going. Find the sum of the measure of the interior angles of a convex polygon. So what do we need to figure out about these polygons to do this? How many sides there are. So on example 1, how many sides are there? 5 sides. 1, 2, 3, 4, 5. So n equals 5. We're going to take 5 minus, that's not great, 5 minus 2 times 180. 5 minus 2 is 3. Then multiply it by 180. 540 degrees. Make sure that you're following your order of operations, meaning that you do what's in the parentheses first. If you don't, then you would end up with a negative number, and hopefully you would realize that you shouldn't have a negative number for angles, at least not in this class. All right, number 2, how many sides? 1, 2, 3, 4, 5, 6, 7. So we take 7 minus 2 times 180. 7 minus 2 is 5 times 180. 900 degrees if we were to add up all those angles. All right, on example 3, how many sides? 8, n is equal to 8. So we take 8 minus 2, which is 6, times 180. 1080 degrees. Easy enough? Questions, concerns about it? Need more time with it? Okay. So on the next set of examples, we make it just a little bit more interesting. We're trying to find the measure of angle A. Now, example 4, you should already be able to do. What kind of polygon is it? A quadrilateral. And you should know, without even using the formula, that a quadrilateral, all the angles inside add up to 360. So you don't necessarily have to use the formula there to find the sum. So we're going to take 360 and do what? Subtract what? Subtract all the other angles. So if you want to add them all together first, that's fine. Or you can just minus 74 minus 74 minus 68. Are we all okay with 216? 216? Something about that seems big to me. Oh, if you add all those together, you get 216? Is that what you're saying? Okay, so what happens when we subtract them all off? 144. Okay, that sounds better. I was like, that sounded kind of big for a sum, for the one angle there. Are we all good with that? So if we were to add all these together, we would get 216, and that's what we were subtracting from the 360. All right, example 5. This time we don't have a quadrilateral. How many sides do we have? 5 sides. Now, I think we just did this one, but we should be doing 5 minus 2 times 180 first. What does that give me? 540 degrees. So that's what we get if we add all of them together. So to figure out the one that we're missing, we're just going to subtract the ones that we know. So 540 minus 104 minus 94 minus 114 minus 108. 120. Anybody else agree with that? I don't have a calculator, so I'm relying on you to check each other. Seems reasonable. On example 6, how many sides do I have? 6. If counting the sides is tricky for you, you can count the angles. There should be the same number of sides as there are angles. So if it's easier to go around and count all the angles, that's fine. So we would take 6 minus 2 times 180 to figure out the sum of the angles. What would we get? 720 degrees for the sum. So to find the one that we don't know, we're going to take 720 and subtract all those angles. Again, if you prefer to add them all up before you subtract them, that's fine. Anybody get an answer?
35.
Anybody agree with 35 degrees? Oh, 65?
60.
Are we okay with 65 degrees? That's what everybody got? Okay. These ones are pretty easy using a calculator. Just make sure you type it into your calculator correctly. Don't try to go too fast. All right, on the back we have our other big idea. First big idea had to do with the sum of the interior angles. This one has to do with the sum of the exterior angles. Let you write for a moment before we talk about it. All right, the sum of the measure of the exterior angles of a convex polygon is 360 degrees. Now, in my personal opinion, it might mean a little bit more or hit home a little bit more if instead of the word a convex polygon, we put the word any convex polygon. This means it doesn't matter how many sides it has. They showed us a pentagon with 5 sides as an example here, but it doesn't matter. It's any convex polygon. If you add up the angles outside, it's 360 degrees every single time. Whether it has 5 sides or 50 sides, it's going to be 360 degrees outside of it every single time. This does hinge on the fact that we only make one angle outside at each vertex. Okay, see how they didn't extend the lines in both directions? They only went one way from each vertex. We have questions about this one? Okay. This one should, in my opinion, be one of the easiest things to remember, but some students get caught up on the fact that the interior ones, it matters how many sides there are, so they think it should matter for exterior, but that's not the case. For interior, how many sides there are matters. For exterior, it's always going to add up to 360. We ready to move on? Take your silence as a yes. All right, find the value of x. We've got some convex polygons. We've got the angles outside of the polygon, exterior angles. So all these angles that they show us on each polygon should add up to 360. If you want to go ahead and combine like terms as you go, that's fine. If I'm adding up these angles, I would add x to what? X. X plus x is 2x. Ooh, iPad's falling behind on me. All right, 2x plus, if I add up all those whole number degrees, what would I get? 260, and I should be setting this equal to 360. To solve for x, I need to, 2x equals, and then divide x equals 50. Okay, when you're solving for x instead of solving for the angle itself, you don't necessarily need to put the degree symbol. If you were to put it on there, that'd be fine. All right, on number 8. Again, if we're adding up all these angles, they should get set equal to 360. So I would have x plus 290 equals 360, which means x equals 70. Questions, concerns? Need more time on this slide? Warm, fuzzy feelings all around. Okay, on we go. We're still working with angles outside of a polygon, so they should still add up to 360. So what equation did we set up on number 9? Very good. First we subtract 2x equals 160, then we divide x equals 80. Okay, if we're dealing with the exterior angles, it doesn't matter how many angles there are. We're adding them all up to equal 360. On this last one, number 10, they didn't label all 3 of our exterior angles. What is that one that they left blank? 90, good. So we should know that if there's a right angle on the inside, there's also going to be a right angle there on the outside. So when I add all of these angles up, what does my equation look like? Oh, thank you. Okay, so if we write it all out, 8x plus 6x plus 4 plus that 90 gets set equal to 360. Combine like terms. What's 8x plus 6x? 14x plus. Good. Now we need to subtract. 14x equals. And then what do we get? 19. Sounds good to me. Questions, concerns? Can we keep these 2 ideas separate from each other? Okay, there's one other question I want to talk about real quick. I'm not sure if it comes up on your homework or not, but I'll write it up here. All right, so the extra question I want to go over is find the measure of one interior angle and one exterior angle of a regular hexagon. We talked about what regular meant the other day. What does regular mean? Okay, so a couple ways we could phrase it. It's both equiangular and equilateral, which means all the sides are congruent and all the angles are congruent. Normally, using the formula and the other theorem about exterior angles, we can only decide on the sum of all of the angles. However, if it's regular, we know that the sum has to get split evenly amongst all the angles. So the first step for a problem like this is to figure out the sum. So if we're going to focus on the interior angle, the first step is to find the sum. How would I find the sum of the interior angles? Good. So we use that formula. 6 minus 2 times 180. What do we get? 720 degrees. So that's if I were to add all of the angles together. But I want to split that evenly between all of the angles so that all of them are congruent. So what do you think I need to do here? Divide by 6. So we're going to take that sum and divide it by how many angles there were. When we do that, what do we get? 120 degrees. So that would be for one interior angle. Ooh. So for exterior, what's the sum going to be? 360, because it's always 360. But again, we need to divide it evenly, so we're going to divide it by 6 again, and we would get 60 degrees for one exterior angle. What do you notice about the interior and exterior angles? That is an interesting relationship. I don't think it always happens that way. Anything else we notice about them? So that's what Bella was saying, but I think that's just a coincidence on this one. Anything else we notice about 120 and 60? Maybe a vocab word we could use to describe them? Supplementary! That will always be true. If you have a regular polygon, or really any polygon, if you take one interior and match it up with the exterior right next to it, they should add up to 180 because they would make a straight line. Okay. Questions, concerns about anything we've talked about? Okay, like I said, I'm not sure if this idea of regular pops up on your homework or not, but it could, so I wanted to make sure we talked about it. This only works, this whole dividing by the number of angles only works when it's regular. If they don't tell us it's regular, then not all of the angles need to be the same, which we saw on the front and the back with our examples. The angles were different numbers.